Good afternoon, this is Ms. Parks, and in section 7.2, we're going to be doing the ambiguous case of law of sines. So when they give you two angles, then you have a triangle. There's no decision making, there's one triangle. However, if they only give you one angle and two sides, then it's possible that you're not going to have any triangles, that you might have one triangle, that you might have two triangles. So let me see if I could try to explain. So if I'm given two sides, like the length of this side, I don't know, is 10, and then an angle. So I know that this angle is, let's say, 80. And then I know that this side is, let's say, maybe 5. Then there's not going to be a triangle. That's not enough. That's not long enough to reach the other side if this is an 80-degree angle. So it's possible that you're not going to have a triangle. Now, if I have this last side here and it reaches here, that would be one triangle, but also if it reaches here, it could be a second triangle. So it's possible that if I know this angle is maybe 50 and I know the length of this, and I know the length of this green side, then and the length of the pink side, I don't know if the pink side is going to go in at this angle or if it's going to go out at that angle. So that would make two separate triangles with the same numbers. So we just basically have to do the math to figure this out. And I'm going to show you how to do that. So this is only the case when they give you side-side angle only. Okay, so one angle only is given to you. All right, so let me go ahead and just write this out. Angle ABC and side ABC. And for now, you can go ahead and just disregard the feet part of this. So angle A, 55.3. Side A, 22.8. As soon as you have a side and an angle that are same letter, that automatically means you're using law of sines and not law of cosines. And then side B is 24.9. Now, because I don't have two angles, then it's possible that I have one triangle, two triangles, or none. So first, let's make sure we have a triangle. So we're going to do sine of A over A, which is 22.8, equals sine of B over 24.9. Now, when we cross multiply, you're going to multiply this times this, and you're going to divide by that. And that will give you sine of B. It's not going to actually give you an answer for the angle, but it will give you sine of B. So that decimal in your calculator is going to be 0.897 and then a bunch of numbers after it. I want you to leave all of those numbers in there. When we leave all those numbers in there, we're going to have an exact answer. So if this number was bigger than 1, we wouldn't have a triangle because you can't take inverse sine. So we're definitely going to have a triangle. We might have two. So we take the inverse sine of both sides. When you put that in your calculator, you should be able to do the inverse sine of your last answer. So look for the button on your calculator that says ANS. For a lot of people, it's above the equal sign for a lot of people. And for some of you, you have your own dedicated answer button. What that does is if you do inverse sine, it'll put that last answer in your calculator. Let me show you what the answer is so you know. So angle B is 63.9 degrees. Okay, so that's B1. This is my triangle 1, first triangle. For my second triangle, A, B, C, what you're going to do is for the second, so if you get B1, the first angle is a B, then you're going to need B2. B2 will be 180 minus 63.9. So the second B value is going to be 116.1. Now, we still don't know if we have a second triangle or not. Let me show you how to decide that. So here's the given information. Okay, the given information is 55.3, 22.8, and 24.9. You cannot change the given information. The second triangle still has those same values. Now, when I write this value in, the 116.1 degrees, if these two angles are over 180, we can't not finish that. It would be impossible because you can't have an angle C in that case. But because these two angles are not over 180, that means that we will have a second triangle, and that second triangle will have a C value of 8.6 degrees because these add up to 180. This C value right here at the top for the first triangle is 60.8 degrees because those three add up to 180. So now all we have to do is we have to have one more equation each to find the C value. And we still use this part to start because that's the part that was given in the first place. So for the top, sine of 55.3 over 22.8. And then sine of C, 60.8 over C. Second part, same thing. And then sine of C, which is 8.6 over C. So when you cross multiply, this times this, divided by that, this times this, divided by that. For the top one, we get C is equal to 24.2. And those are feet. And for the bottom one, we get 4.1. Okay, so the second one is an obtuse triangle. The first one is an acute triangle. And that's what you get. All right, so I would like you guys to try the next problem, please. Okay, here we go. A, B, C. In this case, A is 43.5, A is 10.7, and C is 7.2. So, sine of 43.5 over 10.7, sine of C over 7.2. We cross multiply these two together, divide by that. This will give you sine of C is equal to 0.463, etc. Yes, you need to write this step down. Okay, you must write this step down. Then you'll be doing inverse sine of both sides, and C will come out to be 27.6 degrees. That means that C2 will be 180 minus that for the second triangle, which will be 152.4 degrees. So that means in the second triangle, 43.5, 10.7, and this is 152.4. Now, there's a couple reasons why the second triangle cannot exist. One reason is because these two angles are over 180. The second one, I don't know if you could tell, see if you can figure out why the second one can't be a triangle besides the fact that those are over 180. Remember that the smaller the angle has to be across from the shorter side. So this angle would actually have to be smaller than 43.5 to give you 7.2. But also these two angles are over 180. So there is no triangle 2, but there is a triangle 1. So we need to finish up triangle 1. These two angles add up to whatever, and then you subtract them from 180, you should get 108.9. That means that sine of 43.5 over 10.7, and then for B, sine of 108.9 over B, and you should get for B 14.7, and those are inches. So in this case, there's only one triangle. You still have to check for a second triangle because it's possible, but because A plus C is over 180 degrees, then it can't be, and also angle C has to be smaller than angle A. All right, let's go ahead and try the next one. Same thing, go ahead and set it up and see what you get. All right, so they give us B. And you should have already finished this, all right, before me. If not, please do that first. So pause the video if you're not done with it. All right, so we got to find A. So sine of A over 25.1, sine of 55.2 over 8.94. All right, so if I cross multiply here, this times this, divided by that, I will get sine of A is equal to 2.305. You can't have a number here that's bigger than 1. It's not going to work. So if you do inverse sine of both sides, you're going to get an error. That means that it's impossible. So there is no triangle here. Okay, there's not one, there's not two triangles, there aren't any triangles. All right, so you've covered every single type. So we covered the first one, which was 2 different triangles. We covered the second one, which was only 1 triangle. And then we covered the third kind, which there are no triangles. So they're all exactly the same type of question. So I'm actually not going to do these next 3 examples. If you would like to practice them, let me know. I mean, just go ahead and do it. Practice them. Maybe I'll put them in as a little short, like, quiz or assignment to have you do them, okay? And then we can go over that. But I am going to go over example 7. And so this is a way that you can sometimes know whether or not you're going to have a triangle before you do the work. So if we wrote down A, B, C for the angles, and ABC for the sides. So this is 104 degrees for A. That's 26.8 meters, and B is 31.3 meters. So there is a way to tell what's going on here without doing any work. Okay, so if you can analyze what you have here, you have an obtuse triangle. Whenever you have an obtuse triangle, the side that's across from it definitely has to be the longest side. So if this is 104 degrees, and that's angle A, and this is 26.8 meters, and let's say this is B, there's no way that side B can be longer. It's impossible. So there's no triangle here because that side A must be the longest side if angle A is obtuse. All right, so I didn't want to go over that one because there's times where you don't have to do that. But when you say that there's no triangle and you don't show any work, you need to write an explanation. Okay, otherwise it's not acceptable. So that's it for section 7.2 with lost signs. So this is, again, lost signs when you're given one side and one angle that are across from each other, but only one angle total, so side angle. And then we're going to do law of cosines next.